All right, today we're working on learning targets proportional parts. We are going to start off with just a quick review of what proportion means, and then we are going to go from there. All right, so let's take a look at our review. Problem number 1 says circle the model that can form a proportion with 10 over 15. So remember, proportions are two ratios or fractions that are equivalent to each other. So to do this the easiest, we want to reduce the 10 over 15. So I look at them and I can divide them both, the numerator and the denominator, by 5. All right, so that means they reduced to 2 over 3. Okay, so I want an equivalent fraction to that. So I look at this and I have 1, 2, 3, 4, 5, 6. 6 out of the total 8 are shaded. So this one is 6 over 8, which reduces to 3 over 4. Okay, divide them both by 2. All right, over here I have 1, 2, 3, 4 out of the total 6. So 4 out of 6 are shaded, which does reduce to 2/3. So that one works. Let's just check the last one. I have 1, 2, 3 out of 4, which is 3/4. So that does not work. Okay, so that one is equivalent. It forms a proportion. Circle the ratios that you can use to form a proportion, meaning which two, once again, are equivalent to each other. So the easiest thing to do, guys, is take a look at the ones that aren't reduced and reduce them first. 1/2 is simplified. 3/4 is simplified. 25 over 100 is not. I can divide both my numerator and my denominator by 25, which leaves me with 1 over 4. All right. I can divide for 75 over 100, divide them both by 25, and that leaves me 3 over 4. So that means I see that these two are proportional. They're equal, equivalent. All right, number 3, cross out the proportion that does not have the same solution as the others. Now, you can sit here and you can go through and solve them all to see which one doesn't work. That's a long way, but it will work. Or you can take a look and let's think logically. If I were to look at this first one and I cross multiply, which number am I multiplying my variable by? By the 17. Okay. Take a look at my second one. If I cross multiply, which number am I multiplying my variable by? 17. All right, so clearly those two are work, so I'm good to go. All right, the next one, I cross multiply, and this time it's 12 times n. And my last one, I cross multiply again, and it's 17 times n. So which is the one that was different? I didn't multiply the variable by the same number as the others. It's this one. Okay, it's that one. It's not the same. All right. Let's get into what we're talking about today. Before we can, there's just a word that we need to learn and make sure we know about. Some of you may know already. But the vocab word for today is bisector. What is a bisector? We've talked about it before with drawing line bisectors or segment bisectors and all that stuff. But a bisector divides a whole into 2 equal parts, okay? A whole into 2 equal parts. So a bisector is a point, segment, ray, or line that divides an angle or segment into 2 congruent angles or segments. So we've mainly looked at it with segments, but it can happen for an angle or anything. It's just important to know that it divides into 2 equal parts. Okay. Vocab refresh. Use the diagram at the right. Complete each statement with a correct word from the list below. Use each word only once, blah, blah, blah. Okay. So BD is the blank of ABC. BD is the what? It's the bisector. Okay, you can't say BD is the bisects. That doesn't make sense. Number 5, angle ABC is blank by BD. It is bisected. So really, we're just testing your English language abilities right here. And then BD bisects angle ABC. Okay, so bisector, we're going to use that in a little bit. Let's go on and learn some new stuff. Yay. A shout out to my Period 2 class. Hello, guys. You better be watching this. All right, so Theorem 7.4, the side splitter theorem and its corollary. What? Let's talk about it. So the side splitter theorem really does what it sounds like. It splits a side, splits it. So if a line is parallel to one side of a triangle and it intersects the other 2 sides, then it divides those sides proportionally. Let's take a look. In this diagram, it says if RS is parallel to XY. So here are my parallel sides, and we can tell once again by the arrow drawn on it. Okay. So if a line is parallel to one side of a triangle, so that's what it's saying, line RS is parallel to XY, and it intersects the other two sides. So RS has to touch both of the other sides. I'll draw the other sides in blue. Here are the other sides. Okay, so if line RS is parallel to one of the sides of the triangle and it touches the other two sides, then this can happen. What it does is it divides the two sides proportionally. So what we're saying is that if you take XR, this part right here, and you put it in a ratio with RQ, so I have XR over RQ, that's going to equal to something over SQ. Well, here's SQ, so that something is going to be SY or YS. Okay, so the two sides are proportional to each other. Let's talk about this with numbers. If XR equals 4, so this little chunk right here from the X to the R is 4 inches, we'll say, and RQ is 4 inches, and YS is 5. We need to find this side right here. So we can use a proportion to find it. Now, you can tell and see that if these two are the same, these two have to be the same. But let's take a look at setting up a proportion just for argument's sake. So 4 over 4 equals 5 over, we'll say x, just for solving. 4 times x is 4x. 5 times 4 is 20, so I get 5. Okay, so now I can take, what it's saying is I can take the parts of the sides, assuming I'm talking parallel lines in here. Let's re-mark our diagram for the next one. Okay, so if XR is 3, so if this part is 3, the little guy, and RQ is 6, YS is 4, we need to find this one. I'm going to put it a Y this time. So I'm going to set up a proportion. 3 over 6 is equal to 4 over Y. Okay, because our sides are proportional. I cross multiply. I get 3y equals 24. I divide by 3 and I get 8. Okay, so that is a fun fact that I can use to help me out to find missing side lengths. All right, corollary, meaning another way to think of it. If 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. Okay, same thing except we're just not looking at a triangle. So pretty much if parallel lines are cut by lines, other lines, we're talking proportionality between the sides. So if A, B, and C are parallel, A, B, and C, then AB over BC, okay, so the chunks in between, is equal to WX, oh, that was supposed to be red, WX over XY. Okay, so same thing, pretty much. All right, so let's complete each proportion. BC over AB. So BC from here to here over AB is going to be equal to XY over WX. So really what we're just doing is we're taking that proportion, we're flipping it around. Okay, now if I have something over BA, BA is the chunk up here, is equal to YX over XW. All right, so the missing part is going to be the one that's across from this, so it's going to be CB. Let me erase things. All right, last one, AC. So this one's new. AC is the entire thing, so that's okay. We can say the whole to parts. So AC is to AB, the little chunk, as something is to WX, the little chunk. All right, so what's going to be proportional, or what's going to be compatible with the AC? It's going to be the whole line, the WY. All right, so I'm either comparing parts to parts or parts to whole. Okay, so let's actually use this to solve some problems. Using the side splitter theorem, what is the value of A in the diagram at the right? All right, well, I can use side splitter because I have parallel lines. Remember, it's not just going to work for any triangle. Lines have to be parallel. So I can use the part. I can say A over A plus 4 equals 12 over 18. And now I will cross multiply to solve. 12 times A plus 4, 18 times A. I get 12A plus 48 equals 18A. I subtract 12A on both sides, I get 6A. If I divide by 6, I get 8. So A is equal to 8. Okay? All right. Extra credit? No, just kidding. Not extra credit. High five if you can come up with another proportion to solve this to bring it to your teacher. And it cannot just be this proportion flipped around. It has to be thinking of what I said earlier about parts and wholes. If you can come up with another way, bring it to your teacher and they will give you a high five. Make sure you're telling your teachers about that, though. All right, so I'm going to pause the video. I want you to try the next one on your own. It says 3 campsites are shown in the diagram. Clearly, I want site C. It's bigger. What is the length of site C along the road? Okay, what is the length of it? So you need to find this part down here. Hint, set up a proportion. I'm going to pause the video now. All right, there you go. Check it out. Notice one thing real quick. If I'm given units in a problem, I need units on my answer. Okay, you will lose credit for that. So heads up, yards. All right, so set up a proportion. I didn't use this 9 right here because I don't know the other side. It's not helping me, so I'm just not relevant. So 7.2 over x equals 8 over 6.4. And I did math. All right, pause it if you need to. We're going to move on. All right, talking about splitting things. So theorem number 7.5, triangle angle bisector theorem. Say that 5 times fast. All right, the triangle angle bisector theorem. If a ray bisects an angle of a triangle, meaning it cuts it into 2, then it also divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. What? Let's look. So it's saying that if AD, so if this line right here bisects CAB, meaning cut it in half, and they've already put those angle markings for us, how convenient, then what happens is this, CD, I'm going to outline that in green, over DB is equal to CA over BA. Okay, so we're talking about the bottom cut into parts and then the other side of the triangle. Okay, so let's take a look at a problem like this. What's the value of y in the diagram at the right? Okay, so this cuts it in parts. We're not saying they're equal, they're proportional. So I'm going to do the bottom over the bottom equals the side over the side. Make sure that when you are writing that second side that you are putting the parts of the triangle together, meaning if I treat this like as in making 2 separate triangles, these 2 are in the same triangle and they need to either both go up top together or both be next to each other in the denominator. Okay, whichever you want to look at it, but they can't be opposite. I should never be cross multiplying 2 numbers in the same triangle for this. Okay, so 9.6 over 16 equals y over 24. 16y equals 230.4. I divide and I get 14.4. Guys, after you get an answer, think about it and think, does it make sense? Okay. I know that the bottom part, these 2 numbers are smaller than the outsides because that's bigger than that. So if I get a number that's smaller than 9.6, clearly I did something wrong. Okay, let's talk about it. Lesson check. Do you know how? What is the value of x in the figure at the right? Circle the proportion you can use to solve the problem. Okay, so looking at this, I'm not given part and part. Now, you can, okay, we'll go there in a second. Hold on. So I'm given the whole bottom is 45, and I'm given the part is 30. So that means when I set up a proportion, I have to do the whole thing to one of the parts. Well, I don't know that whole thing, but let's think about it. This chunk is 10, this chunk is x. So the whole thing is going to be whatever x is plus the 10. So I'm going to use that in my proportion. I want to know which one compares the 2. The 30 and the 45 to the x plus 10 and the 10. Okay, why the 10 and not just the x? Because the 10 is what's across from the 30. Okay, it's what's across from the 30. So my portion is going to be 30 over 45 equals 10 over x plus 10, which is this one right here. Okay, once again, I knew the whole and the part. Now, you also could have just figured out that 45 minus 30 was 15 and done 15 over 30 equals the x over 10, and that's totally the better way to do it, but it's just neither here nor there. Okay, so that would have worked as well. But if you ever get in a pickle and you don't know the part, think of it that way. So if we cross multiply and solve, let's do it with a proportion they give us. 45 times 10 is 450. 30 times x plus 10, I distribute, 450, am I writing on whatever, 30x plus 300, subtract 300, I get 150, divide by 30, I get 5. Woo, okay, 5, good. All right, last page. Just deciding what's going on here. Lesson check. I want you to read through, answer the questions, and see if you can come up with the answer on your own. I'm going to go ahead and pause the video and do it while you're working on it as well. So you pause too. All right, take a look. Why can't we use x? Sorry, why can't we use the side splitter theorem to find x? Well, x is not a side. It's a parallel line. All right, it's not on the side of the diagram. 2, 3, y, and 24 are the sides. So I cannot use that theorem to find x. Okay? And that would be that. All right, bring questions to class. Hello to all the students I had last year that I do not get to see this year. Hope everything's going well. Have a good night.